Okay, this is wastewater treatment certification training, chapter 5, part 4, the last of the physical and biological treatment processes. In this overview, or in this chapter, we're going to talk about ponds and lagoons. Ponds and lagoons. Ponds are typically up to 8 feet deep, and most of them are aerobic. Lagoons are typically greater than 8 feet and are typical aerobic, anaerobic, or facultative. Ponds and lagoons are basically the same thing in the way they're operated, just lagoons are deeper, and typically lagoons are more mechanical aeration, or more mechanically aerated, and ponds are more aerated with algae. Types of ponds and lagoons, you've got stabilization ponds. They receive waste with little or no prior treatment. They're like raw water sewage lagoons and ponds. Oxidation ponds are often arranged in series following primary treatment for extra clarification and extra BOD removal. Polishing ponds are often in series after secondary treatment to provide tertiary treatment. Again, it'll help get rid of some of the solids you have, and it can treat any BOD that's left behind. You have 3 types of ponds and lagoons. Aerobic, they usually have oxygen throughout the depth of the pond. Anaerobic has no oxygen in the pond. And facultative, which are the most common, these have a layer, typically 3 layers. The top layer is aerobic, the bottom layer is anaerobic, and the middle layer is populated with facultative bacteria that can kind of live in both realms. An aerobic pond usually has algae growth supplying some oxygen during the day, but then the bugs will use it up at night. Dissolved oxygen can be provided mechanically and distributed throughout the pond. Anaerobic ponds are lack of dissolved oxygen. The bacteria get energy by fermentation of the waste products. They're useful for industrial waste and for use on farms as manure ponds. If covered, the methane gas can be collected and used to power boilers or generators that produce electricity. Facultative ponds are a mix of aerobic and anaerobic levels. Usually, if it's a pond, it's 4 to 5 feet deep, with the upper 2 feet being aerobic and the bottom 2 feet is anaerobic. Algae provides most of the oxygen in the upper portion of the pond. Deep cell aerated lagoons. Existing ponds may be upgraded to lagoons by deepening the pond and adding mechanical aeration. This results in lagoons being 12 to 18 feet deep. The upper 4 to 6 feet are aerobic. The next 6 to 12 feet are facultative. The bottom of the lagoon is anaerobic. Facultative domestic waste lagoons can become anaerobic if organically overloaded. Detention times for aerobic ponds. It'll take 3 days of detention for the pond to act as a sedimentation pond to allow TSS to settle. 3 to 20 days will give you a prolific growth of algae, but you still have organic material may be carried over in the effluent. 60 days is the minimum time to establish a thriving biological population. You get a 90% reduction in coliforms and 70% reduction in BOD. And if you have 180 days detention, you can get removal efficiencies of up to 85 to 95% BOD5 and TSS, and up to 99% for fecal coliform using controlled discharge ponds. Detention times for facultative ponds in deep cell aerated lagoons, in 20 days, you can get rid of 85% of the BOD. 2 aerated cells are required or recommended. With a polishing lagoon, tapered aeration is recommended as you go to the end. Again, the reason for that is you're trying to create an anoxic section in the lagoon to allow for denitrification. Algae growth. Algae are microscopic plants that require the following for growth: sunlight, carbon dioxide, nitrogen, and phosphorus. During photosynthesis, 1 pound of algae is capable of producing 1.6 pounds of oxygen. The oxygen is then available for bacteria and other organisms, but algae will use that oxygen at night. Aerobic bacteria need oxygen to break down organic matter to carbon dioxide and ammonia. DO will increase during the daylight hours and decrease at night. Due to the production and use of CO2, carbon dioxide, pH may change between day and night in ponds with a lot of algae growth. Shows you the cycle for algae. Photosynthesis in the daylight produces oxygen and glucose. The energy is stored as chemical energy and heat. Then at night, you've got CO2 and water being formed, and the oxygen levels drop. Seasonal algae growth in the winter with ponds covered with ice and snow. Sunlight is not as available due to the algae, and DO cannot enter from the atmosphere. Systems can become septic. If they do become septic, odorous gases may accumulate. You can reduce odors by using one of the following methods. You can remove the ice to allow the oxygen transfer. You can use floating aerators. You can recirculate from an aerobic unit, say an aerated basin. You can use odor masking chemicals, but that just masks the smell. You can use heavy chlorination, but then you must make sure you either dechlorinate or have sufficient detention to allow the chlorine to break down naturally. Sodium nitrate, NaNO3, is an alternative for bacteria that cannot use oxygen. Operational maintenance of stabilization ponds. At startup, there must be at least 1 foot of water in the pond before you start adding raw wastewater or any wastewater. The pH should be kept above 7.5 to aid acid-producing anaerobic bacteria. Sodium carbonate, soda ash, can be added to increase the pH or alkalinity. Anaerobic bacteria produce organic acids, which will cause your pH to drop. You must have effective use of entrance and exit locations and baffle curtains to help reduce short-circuiting problems in your ponds and lagoons. Water will try to find the quickest way out from where it comes in. Scum buildup can block sunlight to the algae and interfere with oxygen transfer. If your ponds become overloaded, you need to operate them in series, or they're being operated in series. You should switch them to parallel to spread the load between the 2 ponds. Pond depths of at least 3 feet are necessary to control weed growth in the pond. Plants along the water's edge can cause problems and should be removed. Banks should be rip-wrapped to control weed growth and deter erosion caused by wind and wave action. Herbicides to control vegetation should only be used as a last resort. And before you use any herbicide, make sure you contact the Division of Water to see what herbicides they approve of being used in these systems. Suspended and floating plants like duckweed with enough wind action will not flourish, but they can become a problem. If they do, removal may be necessary. The only way to get rid of duckweed is pretty much scrape it off the top and dig and throw it out of the lagoon. Aerated lagoons require the same daily inspections used for other facilities, with special emphasis put on the aeration equipment. Maintain a minimum DO of 2.0 milligrams per liter and a pH above 7.5 throughout the cells. Mechanical surface aerators should provide good turbulence and a light amount of froth. Monitor and record the DO, pH, and influent and effluent flow daily. Monitor and record BOD load, TSS, alkalinity, volatile acids, and sludge depth on a regular basis. Check for dead spots where there appears to be no turbulence or mixing. You could have if you're using a aeration system with aeration heads at the bottom of the lagoon, one may have become plugged. Complete periodic inspection and maintenance on the aeration devices should be done regularly. The disadvantage of facultative lagoons, you can have odors from seasonal turnover. BOD removal can vary from 50 to 95%, depending how much algae is in the lagoon at a time. With intermittent sand filtration, facultative lagoons may consistently achieve BOD 5 effluent limits. Significant concentrations of nitrogen and phosphorus can be found in the effluent, as a lot of these systems are very poor at removing nitrogen and phosphorus. A land area requirement for a facultative lagoon, a flow of 1 million gallons per day, requires 30 acres of lagoon at 50 pounds of BOD 5 per acre day. So they have to be big. The lagoon configurations in series, that's where you got water starting going into 1, then it flows to 2, then it flows to 3. In parallel, you split the influent equally between the 2 lagoons to balance the organic load. Deep cell facultative lagoons typically operate with 3 or 4 cells. Cell 1 is usually aerobic, DO at 2.0 minimum with high levels of aeration. Cell 2 can be either aerobic or anoxic. If it's anoxic, it goes facultative DO. Its DO is about 0.5 milligram per liter minimum with lighter aeration. Cell 3 is anoxic all the way through with a DO of 5.5 or less. No aeration, you're just letting the DO levels drop. Cell 4 can be settling in anaerobic with a DO of less than 0.1 and no aeration. If you're operating cell 4 that way, you're going to have to re-aerate your effluent before it's released. The loading criteria for pond, the organic loading is calculated in pounds of BOD per day per acre. Population loading is persons or population served per acre. Hydraulic loading is inches or feet of depth added per day. So organic loading of a pond, the flow to two 500 feet wide by 600 feet long lagoons is 0.5 million gallons per day with an influent concentration of 131 milligrams per liter. What is the organic loading in pounds of BOD 5 per day per acre? It is, these can be found on the bottom of the formula sheet. It'll say formulas for ponds and lagoons. And it's pounds of BOD per day per acre equal pounds of BOD divided by pond surface area per acre. We'll work this one out. So we calculate the pounds of BOD. You get 500,000 gallons per day flow times 8.34 times the concentration of 131 milligrams per liter means you have 546.2 pounds of BOD per day. You calculate your acreage. First, you get the square footage, 500 feet by 600 feet times 2 would be 600 square feet. You divide that. There's a conversion on your sheet to convert square footage to acres. Each acre is 43,560 square feet. So you take your 600,000 square feet divided by 43,560. In your lagoon system, there is 13.77 acres. So you take your pounds of BOD, 546.27, divided by the 13.77 acres, and the organic loading is 39.67 pounds of BOD per day per acre. As usual, now here's one you can work out. Go ahead and work it out, and then we'll go through it together. Okay, what did you get for the organic loading of those 2 ponds? Correct answer, 52.5 pounds of BOD per day per acre. How do we get it? First, calculate the acreage. 740 feet times 550 feet times 2, because there were 2 lagoons, gives you 814,000 square feet divided by 43,560 square feet per acre. Means you've got your lagoons cover 18.69 acres. Calculate your pounds of BOD. 0.7 times 8.34 times 168 milligrams per liter equals 980 pounds of BOD5. 980 pounds of BOD5 divided by 18.69 acres gives you 52.48 pounds of BOD5 per acre per day. Population loading, we'll do this one together. The flow to 2 700-foot long by 600-foot wide lagoons is 0.765 million gallons a day. These lagoons serve a population of 4,200 people. What is the loading in persons per acre? Of course, you've got to calculate your acreage. 600 times 700 times 2, because there's 2 lagoons. That is 840,000 square feet divided by 43,560 square feet per acre. Means your lagoons cover 19.28 acres. You divide the 4,200 people it serves by the 19.28 acres, and you'll see that 217.84 people per acre is the population loading for that system. You knew it. There was going to be one coming for you to do. So here you go. You can do this one. Okay, what'd you get for the answer? Correct answer, A, 98. This one was fairly easy. You had the people, and we gave you the acreage already of the pond. So it's just 900 people divided by 9.81 acres is 98 people per acre. If you take care of your lagoon and everything, follow the right OM, do everything your way you're supposed to, you'll get a fine looking lagoon like this one. You can see the aeration. This uses underground or underwater aerators. A little bit of light froth on top that breaks quickly. Doesn't appear to be any dead areas except maybe over here in the corner. Looks real good. They've got a curtain to keep the flow from running straight through. But if you don't follow your O&M plan for your lagoons, you can end up with a mess. Those aerators aren't even hitting the water. They're floating on top of sludge. So take care of your lagoons, they'll take care of you. That concludes wastewater treatment certification, chapter 5. It's all done now. If you have any questions, you can email them to envhelp@ky.gov or call 502-782-6189. Your question will be forwarded to a trainer who will get in touch with you to help you out.